Hello, my name is Megumi Kohyama, and my presentation is about Park and Hanafin's multimedia design principles. There are three sections to my presentation today. First, I will give a short overview of the framework of multimedia design created by Park and Hanafin and the principles they developed as part of that framework. Second, I will talk about major milestones in the development of this theory, such as when it was developed and what theories influenced its development. Finally, I will talk about some research projects that were influenced by Park and Hanafin's work. Let's begin. Park and Hanafin created the principles for interactive multi-design in their framework by organizing research and theories and then providing guidelines based on empirical evidence. To organize the principles, the researcher placed them in three categories: psychological, pedagogical, technological, and then further divided them into three subcategories: general, component, primary. The 20 principles provide interactive multimedia designers access to the major research findings and the theories in the field, and a way to implement that information into actual design work. Before we move on the principles, I would like to explain the three foundations of theories that Park and Hanafin used to create their framework. The foundations are psychological, which is defined as research and theory that based on individuals' role in processing information. Pedagogical, which is defined as research and theory based on strategies for instruction. And technological, which is defined as research and theory based on capability of technology users. In this presentation, I'm going to introduce three principles of the 20 developed by Park and Hanafin. The first principle is number 1 in Hanafin's framework. Related prior knowledge is the single most powerful influence in mediating subsequent learning. This means that when people learn something new, prior knowledge will be a bridge to the new information. In addition, Park and Hanafin suggest that designers provide multiple layers of information in their materials in order to scaffold learning and provide relevant information to all levels of student. The image on the screen shows an example of this principle in teaching math. I believe everybody has experienced learning addition as a child, not only with numbers but with objects like fruits, trees, cars, or something else related to daily life. Especially for children who are not familiar with numbers, these examples help them understand what is addition and what it works. The second principle is number 14 in Hanafin's framework. Shifting attention improves the learning of a related concept. Learners encounter lots of information, but not all information is important for them. This principle suggests that designers clarify the most important items for learners to differentiate it from other information. For example, we can use highlighting, different colors, fonts, or arrows to do this. This image represents an example of how to differentiate information in a diagram of avatars. The bees that are most important to this lesson are marked with circle, have arrows beside them. The circle and the arrow are highlighted to make them different from other bees to get the runner's attention. The runner's eye goes to the highlighted part first, so that runner does not need to search for the important information in this image. The third principle is number 20 in Hanafin's framework. Learning is facilitated when system features are functionally self-evident, logically organized, easily accessible, and readily deployed. This image is from Khan Academy website. This website provides lecture videos and quizzes to support self-directed learning. Also, it tracks the progress of users' learning and shows their achievement through the earning of points and badges. This is a math quiz page. In this example, in the center of the page, there are several quizzes that the learner has not completed yet, and a start button next to it. The quiz will show up when you click the start button, and when it is finished, a new quiz will appear on the screen. In addition, users of the site can easily see what badges they have earned, on the top of the screen and their progress in the entire math curriculum through the graphic on the right. Because of this intuitive and graphic design, the website can be used by learners of all ages. There are so many theories, psychological, pedagogical, and technological, that influence good media design. Unfortunately, because of the number of them, it is hard for designers to apply them in their daily work. Through Park and Hanafin's organization of these theories and the 20 principles they created based on them, designers can easily use this information in their daily work. Next, I will cover some of the major milestones in the development of Park and Hanafin's principles of interactive multimedia design. These principles were first reported in a 1993 article by Info Park and Michael Hanafin entitled Empirically Based Guidelines for the Design of Interactive Multimedia. Though both Park and Hanafin have published many papers since then, I could not find one which updated the framework. There are many theories that influenced the development of Park and Hanafin's framework, since their work was basically organizing these all of the relevant theories of multimedia design into principles that could be used by practitioners. In fact, there are over 70 separate studies mentioned in Park and Hanafin's article. For example, some of the theories mentioned in the Psychological Foundation are Schema Theory by Norman, Gender, and Stevens 1976, and Symbol Systems by Salomon 1979. In the Pedagogical Foundation, there is Events of Instruction for Computer-Based Instruction by Garnier, Wager, and Rojas 1981, and Elaboration by Hamilton 1990. Finally, in Technical Foundations, Park and Hanafin talk about Cognitive Tools by Kozma 1989, and Human Factors and Economics by Baker 1989. The final section of my presentation is about research that has been developed based on Park and Hanafin's framework. When I entered empirically based guidelines for the design of interactive multimedia into Google Scholar, I found that 296 other researchers had cited it in their work. This shows that this is a very influential framework. However, I was not able to find any research that specifically took all of Park and Hanafin's principles and tried to test them or update their framework. Instead, I found several articles on multimedia design principles that were closely related to the Park and Hanafin's framework and mentioned their work as a direct influence. One of those articles is by Patricia Dubell and is called An Investigation of Behaviorist and Cognitive Approaches to Instructional Multimedia Design. Dubell identified characteristics and difference between behaviorist and cognitive approach because these are the two main approaches in the field. The researcher introduced 8 rules for interface design that are closely related to Park and Hanafin. For example, rule number 1 is to keep cognitive load low. This is equivalent to principle number 1 in Park and Hanafin's framework, which is about layering information and using prior knowledge to facilitate learning, like I mentioned with the picture of addition with apples. Also, rule number 3, which is use media to direct attention. This could be linked to principle number 17, which is about differences in an individual's need for support. Therefore, a precise instructional plan is needed. Another article which caught my interest was Designing Multimedia Games for Young Children's Taxonomic Concept Development. In this 2006 study, the researchers Sang, Chen, and Lee used a pre- and post-test design to measure children's ability to understand thematic and taxonomic relationship. In order to do this, the children in this study played several digital games to practice things like sorting and matching and took several tests before and after these activities. The researchers stated that Park and Hanafin's framework was influential because it is important to base children's learning software design on theory, not just the latest technology Park and Hanafi's framework, the researchers state that it can remind designers to keep theoretical foundations in mind while designing their product. Finally, researchers Moreno and Meyer from the University of California, Santa Barbara cited Park and Harafin as being influential in their study on the effects of adding background music and/or sounds to multimedia instruction. These studies found that adding more audio can result in overload to learners. However, there was some indication that if the audio was well integrated and relevant, it could increase learning with multimedia. In the discussion of the results, the researchers cited two of Park and Hanafin's principles as being important to their study. The principles they mentioned, 7 and 9, seem to be opposite because one of them states learning improves from stimulus related to the learning topic, and the other warns against overload from too much stimulus. The researchers conclude that these opposing views can be explained through cohesion principle, properly integrating stimulus and making it relevant. From doing the research for this presentation, I learned that Park and Hanafin's principles of multimedia design was very influential for researchers and helpful to designers because it gives an organization for a large number of theories and shows practical ways to use that knowledge. I am happy that I learned about this framework and I'm excited to integrate it into my design work. These are the photos I used to make this presentation and I list the reference.